This is Dr. Sridharan from SNS College of Technology. In this video, we are going to see about the electrochemical corrosion. The introduction about wet or electrochemical corrosion. Wet corrosion occurs under the following conditions. When two dissimilar metals or alloys are in contact with each other in the presence of an aqueous solutions or moisture. Then when a metal is exposed to varying concentration of the oxygen or any electrolyte, or call it as wet or electrochemical corrosions. The H2 evaluations type corrosion. Here, when iron metal contacts with a non-oxidizing acid like hydrochloric acid, the metal reacts with the HCl. It releases hydrogen gases. It behaves as an anode and cathode approach. The iron undergoes dissolution to give Fe2 plus ions with the liberation of electrons. The Fe gives Fe2 plus 2 electron. This reaction is an oxidation reaction and happen in anode. And at cathode, the liberated electrons flow from anodic to cathodic part, where H plus ions get reduced to H2 gas, hydrogen gas. The reaction is 2H plus 2 electron. It gives hydrogen gas. The type of reaction is a reduction reaction. The diagram shows the metals reacts with the aqueous, like here hydrochloric acid. The metal gets oxidized. The metal, the ion is iron ion Fe2 plus. The 2 electrons supplied to the H plus ions. It gives the hydrogen gas evolutions. Then next step one, absorption of oxygen or formation of hydroxide ion type corrosion. The surface of iron is usually coated with a thin film of iron oxide. However, if the oxide film develops, some crack will come and anodic areas are created on the surface while the remaining part acts as a cathode. Here, the metals are sometimes observed the manufacturing defect itself accelerates the corrosion by this way. When the iron metal contacts with a neutral solutions of electrolyte or moisture or water in presence of oxygen, OH minus ions are formed. The reactions at anodic side, iron dissolves as Fe2 plus with the liberation of electrons. At cathodic side, the liberated electrons flow from anodic to cathodic part, where the electrons are taken up by the dissolved oxygen. The reaction is of O2 plus H2O plus 2 electron. It gives the 2OH minus. The net corrosion reactions, the formation of the product FeOH twice. The oxygen is present, FeOH twice is easily oxidized, further oxidized, FeOH thrice. The rust formation Fe2O3 with the water molecule. So that the FeOH twice plus oxygen, further oxidation reactions in presence of the moisture, it gives a FeOH thrice. In this slide, we see about the differences between chemical corrosion and electrochemical corrosion. Chemical corrosion, it occurs only in dry condition, whereas in the presence the electrochemical corrosion in the presence of moisture or electrolyte. It is due to the direct chemical attack of the metal by the environment, whereas electrochemical corrosion, it is due to the setup of a large number of cathodic and anodic areas. And third one, even a homogeneous metal surface gets corroded in the chemical corrosion. Here the heterogeneous surface or bimetallic contact is a condition like galvanic corrosions. Corrosion products accumulate in the same place where corrosion occurs. It happens only on the metal surface, whereas the corrosion occurs at the oxides while products formed elsewhere on the surface or the container. Chemical corrosion is a self-controlled. The electrochemical corrosion is continuous process. It follows absorption mechanism, whereas the electrochemical corrosion, it follows electrochemical reactions. Types of electrochemical corrosion: galvanic corrosion and differential aeration corrosion. Here, when two different metals are in contact with each other in presence of aqueous solutions or moisture, galvanic corrosion occurs. Here, the more active metal act as an anode and less active metals act as a cathode. Here we clearly see about the dissimilar metals. It happens the galvanic corrosion. The first one, zinc and iron, and next one is iron and copper. There are the two examples here. The zinc iron dissimilar metals, and the zinc behaves as a anode, iron acts as a cathode because of the more active and less active. And another one example, Fe and copper. Fe is a more active than copper, so that Fe acts as an anode, the copper acts as a cathode. Here the Fe is an Fe couple in which zinc dissolves in preference to iron. Zinc acts as anode, undergoes oxidation, Fe acts as a cathode. And another couple of the compound metals, copper and iron. Iron and copper couple in which iron when dissolves in preference to copper, the Fe acts as an anode and undergoes the corrosion, and copper acts as a cathode. And differential aerations or concentration corrosion. This type of corrosion occurs when a metal is exposed to varying concentration of oxygen or any electrolyte on the surface of the base metal. Metals partially immersed in the water and remaining is contact with the air. If metal is partially immersed in the conducting solutions and the metal part above the solution is more aerated and become cathodic. So the more aerated surface acts as a cathodic, less oxygen conducting surface act as the anode. So in this principle, the metal gets corroded. The type of corrosion is a differential aeration or concentrational corrosion. Thank you.